Works? Yep.
Okay, good. Are you going to use it?
Sure.
I can use it too then.
One more person to come in. Close the door. Well, hello everybody. Welcome to this afternoon's session. My name's Dave Boyle. I'm the Director of Accident Prevention for CHC based here in Vancouver. Working with me today is Aaron and Oksana at the back, so if you have any questions or concerns, we're here to help. We've got feedback forms on the table, as you've been reminded session after session, but they are valuable, so please take some time to put together constructive advice for us. Today I'd like to introduce Geert Mansvelt. He's the founder of Vidron, if I've said that right, which is a business-to-business imaging service using drone technologies. He's also done business development and electronic engineering for Euro Avionics. So I think we're in for an interesting presentation today on the next dimension of situational awareness. Please join me in welcoming Geert to present. Thank you.
Thank you very much. Can everybody hear me? Yeah, okay, thank you. Thanks for your presence. So my name is Geert Mansvelt. I'm here in my role as a product manager for Euro Avionics. That's a German company. I'm actually a Belgian citizen, and yes, that is allowed to work for a German company. My details are below here. So I have an education as an electronics engineer. I was a student pilot in the Belgian Air Force as well. And now I work for 15 years in the area of business development for avionics products. I've been working for 10 years in the display areas, cockpit displays, and now the last 5 years I work for Euro Avionics. And Euro Avionics is a small company. We're about 100 people. And we make one product, and that is a situational awareness computer that originates from a high-end moving map computer. So what I'm trying to keep generic, I'm not going to do a product presentation. I just want to give you a heads-on what is going on the avionics domain if we talk about situational awareness. So I see the group is not too big, so please also keep it interactive. If you have questions during the session, please interrupt, and we can tackle the problem right away. Afterwards also, there is a small demonstration. I brought some demo kit here with me, so I will hook up the projector and show you the real stuff. So yeah, please enjoy. A very wise man taught me to start with a joke in a presentation. So here you see little Timmy who's asking, "We're getting awfully high helicopter bot. Maybe we should head back down." And then the robot responds, "But Timmy, you only built me to go up." So what I want to show with this presentation is that the equipment manufacturers are trying to work as good as possible together with the operators and the helicopter manufacturers to offer the right product for the right place. But your input is really crucial. We really need to know what to make for you. So what happens here hopefully ends up well, but in most cases, that would end up in a crash. And we don't want that. We don't like crashes, I think. So we have quite a couple of crashes in Europe and in US. You all probably went to the other sessions already. I just came out of the session of the IHST, where you saw some dramatic numbers again for the last couple of years. So we try to help to improve that. Now, a question that is put on the table a lot towards the helicopter manufacturers is it the fault of the machine? Is it actually the machine that is not good enough and not capable of bringing us where we want to go? And of course, we all recognize a good rhetorical question. No, we don't believe it's the fault of the machine. So there's two approaches here. I'm from Europe, so there's a European approach. And there is a North American approach to tackle these problems. I first dig into some numbers, and later on I promise you plenty of pictures. So don't worry, there's a few slides with words here, and then we're good to go. So in Europe, what's the first thing we do in Europe when we have a lot of helicopter crashes? Well, we go to the European Union and we order a very expensive study. So we have EASA busy, and I'm not a safety expert, to be honest. I just try to use my remaining analytical brain cells to analyze the numbers and to manage our product roadmap. But what do we see? EASA statistics, 98 till 2009, so 11 years. We have, for big helicopters, above 2,250 kilograms, we have an average of 3.6 accidents per year. That sounds reasonable, I think. And that means that we have about 4 fatalities per year on big helicopters. Saw the numbers this morning. The numbers are a little bit changing, but whatever, that's in a good way. For small helicopters, it looks even more depressing. In the same period, but a little bit, I focused a little bit on the last part, so 2006, 2009, because there's more evidence there. We have an average of 83 accidents per year. I'm talking about Europe, not about the whole of the world, but 83 accidents in small helicopters, with an average of 20.5 fatalities per year. That's EASA statistics. What do we learn from that? That is that, and of course I'm twisting here the numbers just like you would see on Fox News or whatever, but I'm trying to give my own interpretation of what we see with these numbers. We have 2 million flight hours in Europe per year, 5 million landings. I invented a new term, MTBHCC, the mean time between helicopter crash. That means that we have about 25,000 accumulated hours in Europe before there is the next crash of a helicopter. This is just crashes, this is not fatalities. We have about 7,000 registered helicopters in Europe, which is actually pretty few. I mean, compared to North America or to Australia, it's a small number. So again, with my twisted mind, if you think about it, each helicopter in that fleet can fly 3.3 hours before somewhere in Europe a helicopter crashes. And that sounds not a lot. That sounds like really dangerous. Now let's look to the details before we make some definite conclusions. There is the European Helicopter Safety Team, so the counterpart of the US Helicopter Safety Team, and under the umbrella of the International Helicopter Safety Team. They had a report coming out in 2010 on helicopter accidents in a period of 2000-2005. And they were going into the real bowels of what happened during those accidents. So you had some parameters accounted for what happened. Was it control flight into terrain? Was it, and so on. So each flight or each accident was accounted for certain parameters, not only one, there were multiple. And I started to read them, and what I was surprised about is if you think about the complexity of a helicopter and the way it operates, it lands on very confined areas, very dense situations. Most accidents actually happen en route. And by far, most fatal accidents, they happen en route. So not while you're maneuvering, not while you're making a landing on an oil rig or whatever, you happen to have a crash while you're flying en route, most of the time. What's also surprising, that's confirmed this morning in a meeting from IHST, is that only 22% of the accidents actually have an equipment or an aircraft failure. That's also surprising. I mean, if you think about it, we always think, yeah, there is a gauge broken or the engine shuts down or whatever, and the helicopter crashes. No, that's only 22% of the full accidents flow. What we also see, and that is not surprisingly, I think general aviation takes the big stake of accidents. So 45%, and that's also reflected in the numbers of the small helicopter size as well. 45% of the accidents are made by general aviation. Now, what does come back in all these accidents is, if you look at the parameters that are accounted for each accident, there's always number 1, number 2, number 3, pilot judgment, situational awareness, like I said, yeah, flying, how can I say, flying IMC while you're losing control of the situation and so on. So that always comes back. And the strange thing is, we have all that knowledge, and what we do in Europe as a reaction is we put a lot of regulations into place in terms of extra training, extra procedures, which is good up to a certain level. But do we really tackle then the amount of accidents with doing only that? And that's where we have a problem with, I think, and that's where we try to find a solution for. So in most of the cases, it's definitely not the fault of the machine. And I think we know that since a long time. We just don't happen to react on it very well. Now let's go to North America. What's the reaction to a situation like this in North America? And I think it's a more direct approach. In America, instead of ordering a big study, we find a patch for an immediate need. And I give you an example. That's the emergency medical crashes in US that went up drastically in the last couple of years. And they found out that since 2004, all of these crashes were basically controlled flight into terrain. A lot of them. Loss of control or CFIT. So the RTSCA, they made a special committee 212s, to develop a dedicated helicopter terrain avoidance and warning system. So the minimum operation performance standard was established in 2008. That's the DO 309. And in 2008, the FAA released then a formal TSO, C194 for HTOLs. And what is HTOLs about? Well, it's actually skinning the EGPWS that we all know and tailor it to helicopter operations. And what's the big difference? We don't need all the kinetic parameters from the aircraft to take into the helicopter world, because we have the unique ability to hover our aircraft or to fly very, very slow. On top of that, the EGPWS databases, they work with 1,000 meter resolution terrain databases. That's not enough for a helicopter. If you're flying into a valley or close to an oil rig, you want to know precisely how far you are from that object or from that mountain. So that's where the HTOS wants to give an answer to. It uses more detailed terrain information, and it uses primarily the attitude of the helicopter and the altitude to calculate where you're going to. So you're also getting rid of all these nuisance alerts that you would get with the EGPWS. In October 2010, there was a notice for proposed rulemaking to install this system mandatory for all EMS operations. I asked this morning if there was some effect out of that to the EMS community, but that's too fresh to judge at the moment. Now, what I find striking in all the presentations that I've been to today is that we're always comparing the helicopter operations to the airliners or to regional operations or whatever. I don't think that's very fair. I mean, to be honest, a helicopter is made to do a mission. I didn't find the numbers, but I definitely think that Part 29 aircraft, in particular, they're not bought to just fly from A to B or to do a fun flight or whatever. Also, Part 27 aircraft, I think a lot of them, they do actually have a mission. So helicopters, they do tasks that other vehicles cannot do. That's what we use them for. But that also makes them much more vulnerable to accidents. So to compare an airliner or the standards, the safety standards of an airliner and the safety goals that they have achieved so far with today's operations of helicopters, well, I think we are comparing apples with oranges there. So you have helicopters that fly to control high tension lines. These are crazy people. I mean, absolutely, I wouldn't be in that helicopter, but that's happening. You have operations in Afghanistan or all around the world flying in very hazardous terrain, mountainous areas, into desert areas, and so on. You have mountain rescue operations where you have zero visibility or almost zero in icy conditions. So during operations, helicopters, they fly far closer to flight hazardous objects than any fixed-wing aircraft can ever do. So, okay, if we realize that, let's take a measure there instead of trying to achieve the same objectives with airliners, with the measures they take on the airliners to make them safer. So, and our belief is that the need of situational awareness inside the cockpit of these various missions needs to be tailored to that particular mission. Okay, how to do that? Interaction. No. How to do that? Well, we have two problems. And the first one I really don't want to underestimate. That is culture. I come from an avionics display background. And I was there when the first LCD glass cockpits were made and were installed. There was a big hesitation to do that compared to these steam gauge cockpits where you had lots of redundancy and whatever to replace everything with big area displays and so on. So that was, there was a big cultural resistance to do that. Well, now working for Euroavionics, situational awareness in the cockpit has the same kind of resistance because we think that our pilots are going to lose flying skills or are going to have problems to have their mental situational awareness keeping up to a certain level. And is that the fact? Does anybody recognize this cockpit? Sorry? No? This is a Concorde. I know this cockpit very well because when I was a small boy, I got a poster from my dad. It was in my room. So this cockpit was like 20 years of my life. I've been looking to all these dials. Can you imagine that you have to intercept a radio and an approach speed of 190 knots while you have your approach plate on your lap? You have to communicate to air traffic control to know where the other traffic is. You don't have a weather radar. You don't have a TCAS. You know what I mean? So that mental picture in your head is beyond, to my belief, is beyond human normal reach. So no wonder actually that they put a third man there for navigation purposes. I mean, your head would be blowing up if you wanted to do that as well. So I think we've gone past a certain era where we had to make this mental picture ourselves in the cockpit based on information coming from all these dials and making that image in our head of where we were compared to the dangerous objects around the aircraft. Is there anybody in the room that doesn't know the relation between those two objects? I don't think so. We're all dinosaurs, I guess. But so today I don't need a pencil anymore to listen to the same song on my MP3 player anymore. So I can just use the software to handle that. Well, there are even maybe people that don't know what an MP3 player is. But so that's, things are getting better. That's the basic idea. And this is called progress. So some fresh pilots we get into service today, they were trained on a Garmin 1000 cockpit, a beautiful cockpit. It works very, very well. But do they lack any mental situational awareness skills? Do we really think that? I don't think so. Because the same guy in the evening, he's going to try to avoid 50 zombies in his computer game. So he knows very well where he is. So I think we kind of like to keep conservative ideas about we have to keep our pilots and our pilot skills, situational awareness all in our head, while there is now such a beautiful graphical way to help you in the cockpit to fly your operation safely. That's one part of the story. The second part is what I call the reality of the reality. I think that's the buzzword this week, reality of the reality. It's cost. So how are we getting to get this situational awareness in the cockpit? And here I have to agree with my dear customers, which are mainly the helicopter OEMs. If you have a very nice integrated cockpit and you hook it up to your FMS, you hook it up to your AHRS, your radar altimeter, your TCAS system, and eventually, after a few years of work, you get this cockpit level A certified, you don't like to change it anymore. And there I think is really one of the core problems that we're facing today in the helicopter world, and where we're lagging also in cockpit technology, is that the helicopter operators, they might make a very nice aircraft with a very nice integrated cockpit, But each of these helicopters, they will fly out to a different customer with different mission needs. So each of the customers, what does he want to do? He wants to hook up a search engine because he flies EMS operations and he wants to search for a specific address in this area. He wants to connect an electro-optical system because he wants to do some paramilitary operations. He wants to have an HTOS on board because that's very important because he does, for instance, mountainous rescue operations. He wants to have a search radar hooked up because he does some maritime patrol activities or some Coast Guard activities. And he wants to have some electronic charts on his screen because he wants to fly the procedure not on paper but on a digital way. So how do I do that? How do I hook up these operational needs to a cockpit that is level A certified? Well, I tell you, most of the cases, the helicopter OEMs, they just do what the customer wants. And if you want to hook up one of these devices, a SATCOM or a different tactical radio or whatever, my friends at NH Industries, they explained me that out of the 3 original designs of the NH90, there are now 42 avionics versions of the NH90 that are certified. So that's 42 times the cost of a level A certification process for the cockpit. That's ridiculous. So we try to find ways to hook up SATCOMs like the Skytrax SATCOM. We like to help people in realizing their operations and to do them safely in a holistic way. By the way, it's not only about hooking up different types of equipment, it's also giving the right background information to that mission operator. Here's some examples. You would like maybe to see some VFR charts, or you would like to see some high detailed nautical vector data, or you would like to see some houses, some very detailed vectorized information for police or EMS operations, or you want to have some satellite imagery inside for specific reasons like geological survey or whatever. So you all have different needs, equipment-wise, background-wise, databases, whatever. And that level A cockpit that you bought with your very expensive helicopter doesn't give you a gateway to show all that information. That's the big difficulty that the helicopter OEMs have today. And by the way, that's the reason why I'm here. They are learning very fast that there are solutions for this. So what awareness do I need for my specific operations? And I'm not talking to you all, and I think you have a very different background probably. So in most cases, you like to have a very detailed map. Why? I would say legacy. A lot of people, they are still flying with paper maps. They're very familiar with those maps. They know how they look like. Of course, we can add some extra elements, but that's a very basic element. And of course, our map engine inside is key. Secondly, terrain. Very obviously, we're not working in a 2D world, but in a 3D world. And what is different with a car navigation system is that here we also like to know our relation to the terrain that is around us. So we install an EGPWS or an HTOS, and we depict terrain over the map information. Obstacles. Another very important thing. For instance, in Austria, it's not uncommon that there is a lift mounted by a farmer just overnight. So if you have an EMS operation in the mountains and you want to pick up a patient and you don't know that that obstacle is there, every day you're under danger. So obstacles, they can come 2 ways. They can come either by databases that are updated every day or every week or every month, or you have active obstacle detection systems. And actually this system you see here has been hooked up by Rockwell Collins to their new radar obstacle detection system, which is a very small plate, 2 kilometers range. Works fantastically. It gives you full situational awareness on top of the terrain profile. Traffic. We have TCAS, we have TCAS2, we have ACAS, we have ADS-B in. All this information is very, very valuable to be compared and geo-referenced towards the other elements that are surrounding the aircraft. So you have mountains, you You have traffic, you have obstacles on the ground, much more to come. What you also want to see is your flight plan. So we normally, in all the cases where we install our product, we hook up to the FMS. So we get the flight plan information, we know where the holding patterns are, we know what the minimum safe altitudes are that needs to be reached for each leg, and so on. So we visualize that as well. And then you see very clearly the relation towards the terrain. You see again traffic and all the other elements. Weather. Weather is one of the last elements that we added to our situational awareness system, because you had all these legacy radars with their own display in a cockpit and so on. It was not that easy to harmonize that and to find a way to get that added to our system, but now it's a fact, and we're not only supporting weather radars, but also high-end search radars, military radars, and so on. So again, it's one of the last pieces of the puzzle to have complete situational awareness on one image. There is also procedures. We're all carrying a lot of paperwork with us. Every airport has like, I don't know, 6, 7 different ILS approaches for each landing strip. So a lot of, again, mental preparation work, and you can all visualize that very easily and georeference that information, because that is also digitally available now with Jeppesen. We actually have an alliance with Jeppesen. We are the only one that is allowed to make the flight charts transparent, so that you still can read the underlying information. And that's quite important, because again, you have a georeference between the obstacles that are surrounding the aircraft, the airport, the procedure that is there. Also the vertical profile is important. Other systems like AIS, very popular in the offshore industry. You want to know where the oil rigs are and where the big ships are. So you have an AIS receiver on board, and it visualizes the ships with their ship name. Again, this, if you think about it, you have your AIS on board, you have your radar on board, you see some tracks, you put your AIS on, you know what the ship's name is. If you're a SAR operator, you can type in the name of a ship, and we can show you a direct to that ship just by receiving the ship name through the MMSI of the AIS installation. So that holistic approach comes also with the situational awareness system. You are connected to all these systems. You can also gather this information and link them to each other. A direction finder, it's another element that is used, for instance, for search and rescue. We can hook up where the direction finder is looking to and where the targets are. Electro-optical systems, that's a very interesting one. A lot of helicopters are nowadays equipped with a camera. You would be amazed how many helicopters carry one of these very expensive balls with them. And what we do is we are not only showing where the camera is looking at, so that blue trapezoid you see there, that's actually what we call the camera footprint. So that's where the camera is actually looking on the ground. And we show, using the terrain profile, where actual corners of that image are. So it's deformed if there is a mountain in front and so on. Plus, again, you can feed back that information to the internal databases, and here it's fed back to the street database. So you see a street is highlighted in yellow. That is where the focus point of the camera is looking at. So it highlights the street. We automatically can show the street name to the pilot. So again, there's a lot of interactivity that you can activate. What you also can do is to hook up communication devices that bring in target information during flight. And there was lately a conference with Skytrack in Frankfurt where we had some operators. They, during flight, getting new targets in their aircraft, and they know exactly where to go because the information comes from the ground station, the ground mission operations station. They're sending them just over SATCOM new targets, and people can pick those points, indicate a direct to, click it to the autopilot and fly to that point without hesitation. So you save lives, you save time, you save you have more efficiency in your operations. Now, what is the big difficulty with all this information? And everybody asks me this question. Yeah, I have all these sensors connected. That image is going to be way too cluttered for my operations. Well, that's the big art about it. You have to show the right information at the right time. The rule is don't clutter the picture. Just activate what information you need at a specific time in your flight. And also what is difficult is that all this information comes in but needs to be geo-referenced to each other in a correct way, so it can be used for navigational purposes. An example here, This is a VFR chart, very small piece. Doesn't give you a lot of information because it's quite abstract. But if you add a transparent terrain layer on top of that, you have immediately a very good impression of what your situation awareness is compared to the terrain around. And still you keep all the references like the roads, like the airports and so on. Another example, this is for police activities. We overlay the vectorized street database on top of a satellite picture. What this does for the police, and I know I don't like it either, but the colors on these streets, they represent the speed limits of that street. So they immediately know if they hook up a camera to a certain vehicle, they know he's speeding or he's fleeing away for something. So yeah. Another very new application is the overlay of camera information on synthetic generated imagery. So we have our synthetic vision engine inside, I will show you later. If you're bringing a camera picture on top of that, you can enhance that picture and correlate information together. Now, a system is as valuable as its ease of operation, and that's really what is key for our system as well. It is very intuitive. It is very important to be intuitive, that you can activate that layer of information that you really want at a certain moment in time. The pilot workload is big enough, I guess. We don't want to make things more complex. Now, we talked about the different situation awareness layers of information for different missions of operations of helicopters. But also think about the different members in your helicopter. They might have different needs in terms of situation awareness. So what we've done is we have actually certified this system. This is a dual core processing system, the first dual core that is level C certified in Europe. And it allows that you have two completely independent situation awareness pictures going to two independent positions in the aircraft. Normally it's pilot, co-pilot, but it could be cockpit, cabin, depending on the operations. And they really could have completely different information based on the same sensors that are hooked up. You could, for instance, the mission operator might be looking a vector street overlay on his camera picture. So what we do here, we take in the FLIR camera picture, we have a street vector database, and we overlay that in a georeferenced way so he can read the street names on the picture he's looking at. But the pilot might only be interested in the helicopter routes that he's flying in that area. So he might not be interested at all into street names at that moment in time. The mission operator might want to see the map in north-up orientation, where the pilot might prefer heading-up orientation. Or the mission operator wants to see the data in a 2D environment to have a better impression of distances, where the pilot wants to see it in a 3D, in a synthetic vision perspective. So that are all different approaches, not only mission-wise, but also crew-wise, what you want to have in terms of situation awareness. So let's get back to the helicopter cockpit question. How do I get all these different elements, all these different mission-related and crew-related elements in terms of situation awareness? How do I get this connected to my level A cockpit? Well, the way we have been working with the OEMs so far, and which has been proven very successful, is that these level A cockpits, they often have video inputs, and they're now merging to high-definition video inputs, like on the latest Airbus helicopter platforms and so on. So they open up a gateway, which is certified under the level A certification, and we add this level C computer to hook up whatever operational need there is inside a helicopter. We hook up to the other avionics systems that are on board, and and that's very key, since it is a level A system, a level C system, it can be used for navigational purposes. So the image we generate for the cockpit displays can still be used just like your navigation display that you normally would have, only indicating your flight plan and your VOR arrows and so on. So that is actually what we see happening, is that this situation awareness display is replacing the HSI from the past. So you're just replacing a very symbolic oriented image by a full situation awareness picture in the future. Also, the cabin can be hooked up, a cabin screen. And there is literally a very, very big group of avionics equipment that you can think of wanting to be added to this system. So like I said, the system needs to be developed as per level C. So the design assurance level needs to be level C, otherwise you cannot navigate with it. A very famous phrase I got from one of the OEMs was, well, now I finally can take away this sticker in my cockpit just for fun. Because normally when you had a moving map in the cockpit, it was for reference only. You could not navigate with it. Now that is different. That is really changing in the avionics environment. So there's two TSOs that are crucial for this. That is the 165 for digital maps that requires level C. And you have the TSO 194 for HTOS that equally also requires level C. If you bring all that to a certified and qualified computer box, and you open up all these interfaces, or you make sure that you can interface to different equipment, then you can hook it up to the cockpit and offer that capability to the helicopter. And this is not only for Part 29 aircraft. This is not only for Part 27, it's for the full helicopter fleet. We're doing fixed wing operations, we're doing whatever. I mean, military, civil, retrofit, new aircraft. It is a very, very valuable add-on for the safety of your helicopter operations. Any questions in the meantime? Gentlemen? No? I can quickly hook up the demo system, just to give you an idea how this looks in reality. So this is a small data set that I brought with me in Tennessee. I can simulate here a little bit the aircraft parameters. So you see here on the bottom, altitude, radar altitude, ground speed, heading on top of the screen. I can play with these parameters. So for instance, I can climb out, I can accelerate into terrain. This is a little bit hicky because of the simulated parameters I sent to the system, but it gives you an impression of what you're looking at in terms of situational awareness. So what we basically do is we take any kind of map data, we morph it on top of the terrain profile, so you keep all the elements that you normally have on your terrain, and you can overlay any kind of symbology like flight plan information, flight area information, AIS information, obstacles, whatever you want, and you keep a very good impression of situational awareness. Climb out. So that's about it, actually. I don't know if there's any more specific concerns or things that you want to bring up. Yes, please.
You said there's a radar equipment, so you have the possibility to get radar data from the helicopter. Is it possible to connect this system, for example, an outside landing at the snow area or at the area where brownout is a risk, to proceed the picture into the map as an overlay? So if I lost my sight outside,
Yes.
I have no reference, I can look through the monitor and have the picture?
Absolutely. We have the first test actually performed with the helmet-mounted display. So we generate the picture in a helmet-mounted display, synthetic vision. And when the pilot is looking around, we are orienting that picture. So for instance, for whiteout, brownout operations. Same thing with cameras. If you have a FLIR camera on board, you can actually hook up the camera focus point to be the focus point for your synthetic vision picture. So wherever the camera is looking at, and even if he doesn't see it because it's a brownout situation, we can show on our screen the location that he's looking at. So you can look around with your camera and look, is there any obstacles here, or is this a flat area where I can put my sticking out. Yeah. So that's definitely something that's happening. Anything more?
Presumably, if you link all of these up, present them to the crew, you can also put in the parameters beyond which you would want the crew to operate. And therefore, you can visually indicate to the crew and present alternatives if, for example, the weather's too bad, the terrain's too high, and all of that kind of thing. So rather like what do you call it? TCAS, you have a radar advisory maybe. In these systems you can build in the advisory, which is going to indicate to the crew what you as an operator would not want them to go beyond.
Yeah. Yeah.
Is that the way you anticipate this going?
Absolutely. Yeah. And there is, for instance, one of the amendments that we brought to our HTOS system is that you now also can type in before the flight based on the identity or whatever, what is the ceiling of operations. For instance, we have a lot of helicopters in the Alps in Europe that fly with our system, and some of them have performance limits, certain hot airspeeds. So we bring in another color layer that we put on top of the imagery that shows what peaks you simply cannot reach.
But will that happen? Presumably the system will provide the crew with a solution. So if they're going into a situation where they can't achieve the aimless mission or whatever, the system can provide a solution if there is a solution.
Exactly. Another example is, for instance, following approaches. And we're working very hard with several OEMs to provide situational awareness for following approaches. Because you have the connection to the AIS, you have a connection to the radar, you have a rate profile, obstacle data rate. If you think about it, we have all the elements there to do up to a very low wind and safe altitude. We have a very good way of getting you to the highest area. And on top of that, all the movements of other ships and so on can be taken into account to say, okay, if I take this corridor, approach a certain platform, and there is another ship moving into that corridor, I can warn for that information. The data is there, it's just a matter of combining information and giving the right outputs to the pilots or the operators to perform safely. Another example is flight plans. In the past, all flight plans were transmitted in a 2D way. So you had 2D maps, and the flight plan was just a picture on top of the map. Now we get flight plan data in 3-dimensional form into our system. So we can also warn the pilot that, for instance, if it has a certain trajectory that is not meeting with our terrain profile, you can say, hey, there's something wrong here. You're going straight through a mountain, that's not possible. So that's the kind of interaction that we can offer by the holistic approach of combining all this information.
Presumably there's a danger of presenting information to the crew in such a way that they become reliant on it, or too reliant on it, such that their awareness in other respects is decreased. And to give you an example, we had an offshore installation that we positioned close to high ground. Quite recently, the crew made an approach to that installation. The high ground was giving blanking on the radar, and as they were making the approach, the cruise ship was transiting across the approach profile of the aircraft to the installation. They didn't see that until they became visual with it, below 500 feet. Okay, so it wasn't as low as it might have been, but that was a cruise line. Cruise liners are pretty big. So, there are scenarios, I'm sure, where if the crew became terribly reliant on this kind of information, it might give them a false conception of how safe they really are.
But here, for instance, the cruise ship also within the AIS has one contact. So you can see the information from the cruise ship also and point of information on your approach. So, but I understand what you're saying, and like I said, there is a lot of resilience and culture to completely rely on the systems. Like I said, this is the first time that you really have a navigational situational awareness system. So, and again, to come back to our youth that is coming into the helicopters very, very soon now, very used to very graphical depictions, I think they will very much benefit from a very integrated graphical information picture. They can grasp graphical depiction of the surroundings around us. If it is complete, you're completely right. We have to have all the tools on board to visualize what is surrounding us in all weather conditions and whatever visibility. So, yes, but technology-wise, we are there. We can do it.
How much when it comes to gaming?
There is actually one element in our system that really comes out of this morning automotive industry. That's the automatic detection of obstacles by video interpretation. So you might have a high-end car, and nowadays in Mercedes and BMWs it's standard. We have this little camera that detects the traffic signs, the speed limit, and it depicts it in the cockpit of the car. Well, that kind of algorithms we use to analyze video pictures coming from cameras to see where the spot signals in the terrain. But the problem with an avionics standard product is we cannot use Google Earth imagery, we cannot use the way profiles used for the gaming industry. It all needs to go to a DO200 data processing process. So it is not the gaming industry that is offering this information. It really comes from trustworthy sources.
Looking at one ahead into the future, are we going to reach the stage where there's going to be no such thing as iPad life, where basically if you're in IMC conditions, you're just going to have a simulated cockpit display in front of you that's going to portray the things that we've seen anyways that never actually into one of those circumstances?
Well, I strongly believe in that because it is also that the systems like these, you have an FPV of around 6,000 to 7,000 hours. That is way better than the private. So these systems are so reliable now, and the data that is going inside and the sensor information is reliable as well. We really create a virtual VFR environment. And it's not, I mean, our goal is not to stay in the cockpit because I was trained as a pilot to look outside all the time. So that's what really will go into this projection of this imagery on the cockpit windscreen or on the 100-nozzle display in adverse weather situations. We got a letter last year in 2013 from the gendarmerie in France. They were flying the clouds, and they got on the clouds when rising up the mountain. And the guy got vertigo, and the co-pilot took over and was able to stabilize. He switched on the terrain layer, and what they simply did was backtracking from the track that they were doing, going in the direction of that, the way they came from. And it came to be a far condition again. But if they would not have had that kind of tool to show them what's my relation and where am I related to the mountains that I'm flying in, you're always in a very dangerous position. Okay, I realized it was quite short. I thought it took longer, but we had a longer break, I guess. Thank you very much for your attention.
Thank you, Geert,
Thank you very much.
We really appreciate you bringing your vision of the modern cockpit to us. Yes.
Thank you very much. Thank you.
We really want AIS.
Yes.
Yeah.
Yeah, that's really key, huh? Right.
Yeah, very good.
Spreek Nederlands?
Ja.
Engels, mooi.
Ja.
Gaan, Nederland. CHC, Nederland. Hoeveel zijn jullie met het systeem?